Hello everyone, welcome to the chapter of functions. This is the start of it. Um, I would like all of us to refer to section 4.1 and 4.2 of your notes for this part of the lesson. Before we start on the actual function itself, I would like to start off with the idea of relations. Basically, relation is a relationship between a set of numbers here and another set of numbers here. In fact, it may not just be numbers, but in mathematics here in this subject, we will deal with the relationship between two numbers. So you can see there's a set of numbers here and a set of numbers here. There is a relationship. Maybe I let you know the relationship, then you can see why it is the arrows are drawn like that. 4 is a multiple of 2. No problem. 6 is a multiple of 2. 6 is also a multiple of 3. So you can see this arrow, actually, this 6 can point to two different numbers on the set B itself. 10 is also a multiple of 2, at the same time also a multiple of 5. Now you can see that 2, right, is an answer to all three, 2, 4, 6, and 10. So 4 is a multiple of 2, 6 is a multiple of 2, 10 is a multiple of 2. So there are many different relations in this world. And this is only one example, right? And the set of numbers here that we see here is what we call the domain. This set A is called the domain. Don't worry about the terminology yet. I will come back to it again. Next, I want to talk about this idea of an image. Now, the image of 4, terminology, image of 4 is actually 2. The image of 6 is 2 as well as 3, and so on and so forth. So I want all of us to have this understanding of this few terminology first. I give you more examples of relations in the next slide. A relation can be one to one. What do we actually mean? That means here you can see is this relation here in part 1 is this multiplied by 2 equal. So one input will only get one and only one output. 1 multiplied by 2, you get 2. 2 multiplied by 2, you get 4. 3 multiplied by 2, you get 6. So this is what I call a 1-1 relation. Means one number, you will get one and only one image. A relation can also be one to many. This one here, right? One to many. As you can see here, is taught by. You can see your teacher's name here, right? Math can be taught by Tan Wu Ko So, whereas Tamil is taught by Mr. Vera. So it can also be one to many. That is another possible kind of a relation. A relation can also be what we call many to one here. Many to one. You can see this list here. It is the list of classes. Many classes can actually belong to Lynx. And S61 belong to Pegasus. That is assigned the house. That is another kind of relation. It can also be many to many. It can also be many to many, which is what I gave you the example just now, is a multiple of. So basically anything goes in a relation. All right, later we come back to this again, but I want you to understand that this can be many kind of relationships, if you put it that way. There is another rule, another relation, is functions is basically a special type of relation. I repeat, functions are actually a special type of relation in which every element in the domain give exactly one image. Every element in the domain give exactly one image. If I may go back here, which one actually represents a which of the following relation give a function? I give you the quick answer. The quick answer is actually number 1, because that one, every single element here is only given one image. So only this can classify as a function. So go back to this definition here. Every function is a relation where every element gives exactly one image. Of course, we are into math. I want to give some notation to a function. I'll give you a quick example. A function is defined like that. Don't worry about the messy looking thing and the alien looking stuff I will explain. The first part to it is what we call the rule. Meaning this. X is mapped to x squared. The image under x, we'll explain this. The image of x under this function is actually x squared. Right? The image of f, right? The image of x is mapped onto x squared. This is what we call the rule. And the next part in defining all functions, it will define the domain. What it means is what are the members in your set A that you are going to map. Meaning to say this. In this form is a lot clearer, right? That 1, all the numbers 1, -1, 2, and -2 are all going to be mapped to its square. This is the rule, its square, to get a 1 or a 4. So now another definition is this. This is what we call the range. The range of a function is basically the set of all possible images under F. This is quite easy to understand for this example at least, is that now you see here, right, you put in -1, -1, 2, and -2, you square it, you will get either 1 or 4. This one, right, this one, 1 and 4 is just the set of possible images under F. So essentially, this is how we write it. I'm going to pause here for a while, right, for you to digest this part. Okay, you may also refer to your notes and in section 4.2. I think example 1 and 2 are easy examples that you can read on your own. I would leave you to read on